this lesson, we're going to find real zeros of polynomial functions and use them to sketch the graph. To sketch the graph of a polynomial function, follow these steps. Step 1, find the real zeros or the x-intercepts of the function and then plot them. Step 2, then find and plot the y-intercept. Remember, to find the y-intercept, you have to let x be 0. And then third, use the end behavior and these points to complete the graph. Okay, so once you plot all of these points, the zeros and the x and y intercepts there, you'll then be able to, based on the leading coefficient and what type of polynomial it is, you'll be able to sketch the graph or see what the sketch of the graph would look like. So here we're given the graph f of x equals 2x cubed plus 5x squared minus x minus 6. So to find the zeros of this function, we need to first look at all of our potential zeros of the rational zero theorem. So to find that, recall, it's p over q. P is going to be your constant. In this case, it's -6. Q is your leading coefficient, which is 2. So you would have plus or minus the factors of 6. We know that the numbers that give us 6 is 1 times 6 and 2 times 3. On the bottom, the numbers or the factors that give us 2 would be 1 times 2. And so listing all the possible rational zeros there, recall you're going to have to place each number on top underneath a 1. And then do it again with each number on top underneath a 2. Once you do that, you're going to list all of your rational possible zeros there. And here we have plus or minus 1, 2, 3, 6, 1/2, and 3/2. So those are all the combinations of numbers, different unique numbers we can make with P over Q. Now, we're going to pick one number from that list to see if it is a 0. Let's start with 1. So what that means is we're going to use synthetic division and 1 as our divisor to see if 1 is a 0. So recall, if we do synthetic division and we wind up with a 0 as our remainder, then that means that 1 indeed would be a 0 of this function. So let's go ahead and plug that in and see if that's the case. So recall, when we're doing synthetic division, you only have your variables there and you have your divisor there on the outside, which is your k here. So step 1, we're going to bring down the first term. So bring down a 2, multiply that with 1 to get 2. Bring down a 7, multiply that with 1 to get 7. Bring down a 6, multiply that with 1 to get 6, and we will bring down a 0, and since the remainder is 0, that is proof that 1 is a 0 of this polynomial function. Again, whenever you plug that into the synthetic division and your last number, which is your remainder, if it's 0, that is your proof that 1, in this case, is a 0 of the given polynomial function. Okay, so again, we had a 0 as our remainder, which proved that 1 is a factor there. And recall, when you write your answer, you write it in terms of the polynomial 1 degree less than the original polynomial. If the original polynomial had a highest degree of 3, we're going to write our answer then starting with degree 2. So that would be 2x squared plus 7x plus 6. And again, remember, we have a 0 remainder. All right, so that would be one of its factors, and then times the divisor is also one of its factors. So you have x minus 1, and notice it's x minus 1 when you put the variables back. When you put it in the form of x minus k, it would be x minus 1. So we have x minus 1 times 2x squared plus 7x plus 6. Now, we can probably factor this trinomial into 2 binomials. So let's go ahead and see if that factors. And sure enough, it does factor. It factors into 2x plus 3 times x plus 2. And as you can see, the highest degree of our given polynomial function is 3, which indicates that there were going to be 3 zeros of 3 factors. And we now have the 3 factors of this polynomial function. Now, to find the zeros, all we need to do is take those linear factors and set them equal to 0 and solve for x. So solving the first one for x, we can see that x would equal 1. Solving the second factor, linear factor there, we would see that x would equal negative 3/2. And then solving the last one for x, x would equal negative 2. So those are our zeros. They're also called x-intercepts. So you have that number in x's place, and then you'll have a 0 in y's place. Lastly, we want to find the y-intercept, and to find the y-intercept, you're going to let x be 0. So remove all the x's and replace them with 0. We can readily see that our output would be negative 6. So our y-intercept is 0, negative 6. All right, so I think we have enough points now where we can go ahead and begin plotting these points and see if we can see the sketch of our graph. So on the next page, let's go ahead and plot these points. All right, so there are the points. We've plotted those points. We've plotted the zeros, or what also known as the x-intercepts, and we plotted the y-intercept. Now let's take a look at the end behavior. So recall, it is the leading term, its degree, as well as the coefficient of that leading term that determines the end behavior. So first of all, the degree of the polynomial is 3. 3 is an odd number, so you know it's going to have some sort of S shape. And the fact that the coefficient of the leading term is a positive number, that indicates that it's going to be moving from left to right in an upward motion, a rise. And so if we just follow the sketch of the dots that we have, our graph is going to look something like this. Now, you can also plug in points for x and see what you get out for y, create a table of value, and you can certainly plug in more points other than 0 and get your ordered pairs, and then when you can see the graph enough to sketch it, you would go ahead and sketch it. But just knowing the end behavior and having a few points, we can kind of get an idea of what the graph will look like.
Okay, that's it for this lesson. Thank you for watching MVP Tutorials by your instructor, Dr. Speights. I hope you'll join me in the next lesson. Please feel free to like, share, and subscribe. Goodbye for now.